Hey guys, so today we're going to go over the two equations of a line, or the two formats for equations of a line. So most of the time in Delta Math, when they ask for an equation of a line, they're looking for this equation of a line, slope-intercept form. So the slope is m, b is the y-intercept on the graph, so that's usually the equation of the line they're looking for. But occasionally they're going to ask for point-slope form. This is where you can pick out m as the slope of your equation, and you use one of your points in the equation of your line. So x1, y1 is a point on the line. X and y just kind of stay there in the equation just like they do in this equation, right? So if I have something like this and I want slope-intercept form, I want this y equals mx plus b form. If I have the slope and I have the y-intercept, I can just plug it straight in, right? So y equals mx plus b. Of course, you don't have to have the plus 0 there if it's just a 0. You could just have y equals negative 5/4 x. This one would be y equals mx plus b, right? So y equals negative 1/4 x plus 2, or sometimes that's written as negative x over 4 plus 2. Okay, now down here, you'll see this does not have y by itself like it does up here in the slope-intercept form. So when y is not by itself, then we might have to get y by itself in order to write it in slope-intercept form. So you can see this format right here is the point-slope form, and they want it in slope-intercept form, which essentially means solve for y. So I'm going to have to start out by distributing the 1/3. So we'll look something like this. Now 1/3 times negative 3 is negative 3/3, which is negative 1, right? Then I can add the 4 over to the other side, and I'll have 1/3 x. And then when I do plus 4, right? These will cancel, and I'll end up with plus 3. So now I've got it in this y equals mx plus b format, which is what they wanted up here, slope-intercept form, which is just as easy as solving for y, right? Same with this one. Let's distribute, see what we get. So 8/5 x plus, remember fractions, you're going to multiply top times top, bottom times bottom, so we'll get 16/5. Okay, and then I need to subtract 5 over to the other side, but how do I subtract 16/5 minus 5, right? Well, I have to have a common denominator. So in terms of fifths, negative 5 would be 25/5. So let me replace that with a minus 25/5. So that's the same as a negative 5. And then 16/5 minus 25/5 would be negative 9/5, right? Okay, so here we go in that slope-intercept form, right? Slope-intercept. Okay, well, what if we want point-slope form? And we have a point and we have a slope. Well, then it's just as easy as plugging it straight in. This is going to be my x1, y1 that are in my equation up here. Remember, x and y just kind of hang out there. And then slope is going to be my m, right? So it'll look like this. Y minus y1 equals m times x minus x1, right? And if we just want point-slope form, well, I've got it. I just plug in the point, I plug in the slope, and I'm done. It did not say find slope-intercept form, so I don't have to keep going and solve for y. I can just stop right there. Okay? Same with this one. This will be x1, y1. This will be my slope m. So y minus y1 equals m times x minus x1. And again, it doesn't say to do slope-intercept form, which is where you solve for y. It just says point-slope form. So here's the point, here's the slope. We're done, right? So we have to be able to go back and forth between the two different forms. Right here, I have the 2 points on the line, okay? And this section says write point-slope form for the equation, and this section says write slope-intercept form. Okay, we have 2 points for the line for all of these, but point slope form means leave it like this, right? And then slope intercept form means, well, solve for y. Get it into this format, right? So first thing, I don't have a slope here, right? I only have 2 points. So first I've got to find the slope, and you'll remember the slope formula, y2 minus y1 over x2 minus x1. So this will be x1, y1, x2, y2. So I'll have 3 minus a negative 5, so that'll change to a plus, and 5 minus a negative 1, so that'll change to a plus also. So I'm going to get 8 over 6. That will reduce to 4 over 3. I would not change that to a mixed number because slope is rise over run. I like it as 4 over 3. That's a rise 4, run 3. It's easier to put on a graph that way than it is to put 1 1/3 on a graph. How are you going to rise 1 1/3? It's easier just to leave it the improper fraction. Okay, so now that I have the slope, I'm ready to use this equation. I've got my x1 and y1 here. I've got my slope here. I'm ready to just plug it in. So y minus y1, again, it's minus a negative 5, so that's going to change signs, equals m times x minus x1. And since that's x minus a negative 1, it changed signs again there too. And point slope form looks just like this. I don't have to go any further. I am done, right? All right, let's try one more. This one would be x1, y1, x2, y2, right? So first we need the slope. So y2 minus y1 over x2 minus x1, that'll be 4 over negative 2, or negative 2. Now I can use this point with this slope in this equation, right? So y minus y1 equals m times x minus x1. No need to go any further. They wanted point slope form. This is point slope form. I'm done, right? Now down here, we're going to do the same thing because we have a point and it's easy to find the slope. We don't have the y-intercept. So when they say find the slope-intercept form, I'm always going to start with the point and the slope, and then I'm just going to solve for y to get it in the right form. So anytime you're given a point and it's easy enough to find the slope, let's use this point slope form, but then just double check if they ask for slope-intercept form, you just need to solve for y, okay? So I'm going to do my slope formula, y2 minus y1 over x2 minus x1, right? Since I subtract a negative 1, that changed to a plus. I get a negative on top and bottom, which cancel each other. So there's my slope. So if I use x1, y1 with this slope, there's my point and my slope in my point slope formula up here. So y minus y1 equals m times x minus x1, right? I minused a negative again, so it had to change signs. And this is my point slope form, but I want slope intercept form. So let's just solve for y. Let's make it look like this. So we'll distribute, get rid of the parentheses. This will be 4 over 4, which is 1. Negative 4 over 4 is negative 1. And then I can subtract 1 from both sides, and I'll get y equals 1/4 x minus 2. And there we go. There's my slope-intercept form. Y equals 1/4 x. This x is out to the side, not on the bottom. I probably should have made my horizontal, my fraction bar more horizontal so that you can make sure that x is not in the denominator. Okay, so I'll do one more here. Let's find the slope first. All right, so again, I'm not going to change this to a mixed number because this is a nice rise over run format. I'm just going to leave it like that. Then I'm going to do my point slope form, y minus y1 equals m times x minus x1. All right, since I want slope-intercept form, which looks like this, I need to get y by itself. So I'll distribute This will be negative 7/3 x, and then negative times negative will be positive 21/3. Ooh, sorry about that, Belle. I'm multiplying fractions, so top times top over bottom times bottom, right? And this will actually reduce, 21/3 will reduce to a 7. So when I go to subtract this 4 from both sides, I don't have to find a common denominator, right? I'll have negative 7/3 x and then plus 3. Again, that x is not in the denominator of that fraction. I probably should have done more of a horizontal bar there. Okay, this is just a reminder that when you're in Delta Math, if it just asks for the equation of a line, they're asking for y equals mx plus b. Okay, if they want it in slope-intercept form, they will ask for specifically, if they want point-slope form, they will ask specifically for point-slope form. Okay, all right, thanks guys.